Howdy folks, Mr. Reed here, and welcome to One More Question. So what I'm going to be doing right now is actually taking a look at transformations of exponential functions, which is exactly the same as transformations of any general function. So if you were following along for those videos, you're going to feel a lot of comfort with what we're about to do with exponential functions. The only thing that's going to throw a little bit of a wrench into what we're doing is being able to recognize which base exponential function we are currently looking at. So what you want to do is do transformations of exponential functions, specifically using mapping notation. You are in the right place. So let's get to it. All right, now I have a lot of text above me, at least I should when I go to edit this thing. We have a point, and that point is -2, 9. And it is currently sitting on an untransformed exponential function. I've named that function f of x, and it is currently defined as being c of x. A, what is the value of c? So this is fairly easy to do. We can actually just take this point and say, well, if the f of x value or the y value is 9 when the x value is -2, then what I'm looking to do is solve this particular equation. Now, one thing you can actually do, which is sorry about that, which is really neat, is if you are dealing with a negative rational function, people talk about cross multiplying, but it's absolutely true that if you have two fractions set up, or even if they're not in fraction form, and you want to do this to both sides of your equation, you're taking the reciprocal of both sides. If they are equal to begin with, the reciprocal should still be equal afterwards, as long as you don't have anything fishy going on with dividing by zeros, which might throw a wrench into things. Now, that being said, that's not what's going on here, so I can rewrite the reciprocal of my left-hand side as being 1/9. The reciprocal of my right-hand side is actually just not having a negative exponent, so it would be c squared. If that doesn't make a whole lot of sense to you, then what you should do is just say 9 is equal to 1 over c squared, so do the reciprocal part of the negative exponent that's going on, and then do some cross multiplying, get something like 9c squared is equal to 1, or c squared is equal to 1/9, and then we're at the same spot as I was earlier on that line. But I really like the idea of being able to just be flexible with flipping things upside down, basically, on both sides, and setting it up from there. So we have two answers actually for c. My c could be 1/3, but it could also be -1/3, except for if you watch the properties video before this one, then you know that c can't be -1/3 because negative bases are not going to be a pretty sight. So it would work technically for this exponent of -2, but it's not generally going to be something that we want to get into. Last time we said that it wouldn't work out if there was a fourth root or whatever that was going on there. Actually, in this case, I'm wrong. It would not work out there either. The way that sorry, it would work good. All right, so blabbing aside, c is equal to 1/3, and that is where we're sitting. So we have that f of x is equal to 1/3 to the power of x. Put some brackets around that so it's a little more clear. Now, what I'm going to do is actually come up with a point, the image point, so the point that's associated with the -2, 9 that we've already developed. We're going to throw that along so that it is instead going to be sitting on a g function, where g is described as a transformation of f. So it's a 3 times vertical stretch factor. It's a horizontal reflection and a 1/5 horizontal stretch factor. It is a translation of 2 units to the right and a translation of 1 unit up. The really awesome thing is we've done this generally. It does not matter that we're paying attention to exponential functions. We're following one point that just happens to be on an exponential function and going through these transformations. It does not matter that it's an exponential function. We can say that any one point, x comma y, is going to map onto 1 over bx plus h, a y plus k. In this case, we are going to map specifically the -2, 9 point onto And we said earlier that this was going to be -1/5, and then we'd have the -2 for the x value, plus h, and that h value is going to be 2, and then a, which is 3, and then the y value is 9, plus k, and that k is 1. So what that means is this point is going to be +2/5 plus 2, which is another 10/5. So that should be 12/5. And 3 times 9 is 27, plus 1 is 28. So we should have a nice point, that is the image point, on 12/5, 28. Hopefully that one was helpful to you. Basically, long story short, is that transformational stuff is going to be really easy if you've worked it out generally, because it really doesn't matter what kind of function we're looking at. The mapping notation stuff, if we were doing a graph-to-graph question, it would work out really well too, just like it did with the radical functions if you've done those ones already. Again, just refer back to what we were doing in talking about general transformations. If you're okay with that, you're going to be great with this, and hopefully you found that one helpful. If you did, like, subscribe, leave comments if you want, and as always, take care, folks.